All right, what's up, guys? So we're starting chapter 1 here. We're going to go through section 1.1 on basically an introduction to set notation. Um, so this is going to be kind of a lot of vocabulary and symbols that you need to know throughout the year, especially first semester. So let's take a look at a little example here. If I have, we'll just pretend that our whole class, we're going to say that is our universal set. So that's the set, the big set that we're working with. We're going to say that each student, we're going to call each student an element of S. Okay? And element is basically looks kind of like an E there. It's a little odd looking E, but that means element. So if I said you're an element of universal set, we would use that symbol. So now, breaking that down, let's just say everybody with blue eyes is set B. All right? So all those blue-eyed people, you guys are all a subset of U, of our universal set. So we'd say B is a subset of U. Okay? And that is, we would signify that by saying B and then subset. It's like that. We say B is a subset of U. That's how we write it. All right, let's just make up another set. Let's say all right-handed students, your set R. Okay, R would be another subset of U. There is a little bit of overlap there probably, but R would be called also another subset of U. Okay. So now we're going to take that a step further. Say everyone in class who is both right-handed and has blue eyes. So you're in both B and R. You're part of the intersection of those sets. And we denote that with this little upside down U symbol. That means intersection. Okay, everybody, basically the overlap. All right, everybody does both of those. All right, going off of that, everyone who is either right-handed or blue eyes would be called the union of B and R. And we denote that with basically a big U, it's like a U. We'd say B union R. So that's everyone who is either right-handed or has blue eyes, or both. Okay? We'll talk about that in a little more detail in the next slide. All right, another set. We'll say all left-handed people, and we'll include ambidextrous people in this. Basically, everybody that's not right-handed. So everybody that's not right-handed is the complement of R. And we denote that with that little symbol there. It's like an apostrophe or a little tick mark. You can write it a variety of ways. That means the complement of R. You might also see it, not in your textbook, but other ones, a little C up there. Okay, it means everything not in R. All right, last thing, all freshmen in this current class. Okay, which there should not be any freshmen in this class. If there are, then I need to check my roster, but there shouldn't be any freshmen in this class. So if I say all freshmen in this class, you would be the empty set because there aren't any. And we denote that with a little circle or a zero with a line through it. It's kind of cut off at the bottom of the screen there. All right. Okay, so important idea to understand before we really get into this is the word or. So when we talk about the word or in probability, in the English language, there's a couple ways to think about it. I want to look at two examples here and decide which one is the correct one. So if you go to Applebee's, you order your meal, your waiter or waitress comes up and says, do you want fries or a salad with that? Okay. Different situation. At Starbucks, you get a coffee, not your mocha latte, pumpkin spice, cinnamon, whatever. All right, just regular coffee. they ask you, do you want cream or sugar? Right? So we used or, but they mean two different things there, or slightly different things. Okay? Think about what is the difference there. Well, up here, fries are a salad. You can't get both and without having to pay extra, right? They're saying one or the other, but not both. With a coffee, they say cream or sugar. You can get cream or sugar. You can also get both. That's the difference. When we talk about probability, and we're using the word or, this is the one we want. Okay, one or the other, or both. That's or in probability. Yep. All right, so some summary of all this with all those symbols again. This is what we went over on the first slide. That included. So up at the top here, we say A, we have a little, looks like an E, we say A is an element of B. So it's part of B. The next one, that symbol is subset, we say A is a subset of B. In other words, everything that's in A is also part of B. So all the blue-eyed people in here were a part of the entire class. All right? The U means union, it's one or the other or both. Okay, either A or B, we add this on there, or both. The upside down one means intersection, means in just both. Okay, the ones they have in common. We'll look at a Venn diagram in the next section, and you'll see that kind of a visual of that. All right. If I have our intersection is the empty set, that means they have nothing in common. Okay, so maybe if we didn't have any right-handed blue-eyed people, that intersection would be the empty set. There aren't any. Okay? If that happens, we say they are disjoint. All right, another term you might have heard before is mutually exclusive. They mean the same thing. Right? Big letter U means universal set. It's where we're taking everything from. It's where we're starting with. B with a little apostrophe or tick mark up there. It means the complement, means everything that's not in B. That's all the symbols right now. Okay, next thing, Cartesian product. Looks more complicated than it is. So let's just say I have sets A and B. So set A, we have the numbers 1, 2, 3. Set B is ABC. If I want to find the Cartesian product, basically it's putting those into ordered pairs and just kind of combining it together. So Cartesian, my Cartesian coordinate plane, it's like your XY plane, we have ordered pairs. It's that idea. So Cartesian product of A and B, I notice the A is first. The order matters here. So basically I just take my first one in A, match it up with the first one in B. There's that. 1 comma A. And then I do 1 in B, 1 color, 1 in C. Okay, and then you just go to the next one. You go 2 in A, 2A, 2B, 2C, and so on. You're just basically matching them all up. There should be 9 pairs. Reason because there's 3 in A and 3 in B. So to know how many pairs you're going to get, it's just however many are in A times however many are in B. 3 times 3. Okay? That's what that is there. So if A had 5, B had 12, okay, there would be 60 pairs in that set. And you're not going to have to do something like that, but it's for example purposes. All right, the little N just tells you, we're signifying how many elements are in that. So this is where if we had 3 elements in A, 3 elements in B, it tells me there's 9 elements in the Cartesian product. Okay, so next section will be on Venn diagrams, which should be familiar to you guys probably from some class. And that's what we will get into next week.